Gravity and Simple Harmonic Motion, Review 1. A celestial body of mass big M and radius r is orbited by a satellite little m at an altitude of 2r above m's surface. You can see the picture there. That's trying to depict what has been described. Derive an expression for the speed v needed for m to follow a circular path around big M. All right, well, I think we should probably use Newton's second law here, and the net force is going to equal the mass times the acceleration. And we're talking about little m here now. So what is the net force on little m? Isn't it the force of gravity on little m, which is big G, big M, little m, divided by the distance between those centers of mass squared, which is going to be 3r quantity squared. So I think it's going to be 9r squared. And that should be equal to the mass that we're talking about, which in fact is little m here, times the acceleration of this mass. The acceleration is a centripetal acceleration, and that acceleration is going to be v squared divided by r. Now what's r? R is the orbital radius, which in this case is 3r, isn't it? That's what's given. Okay, so I think we just need to solve for this. The little m's cancel. That 3r goes away, which makes this denominator 3r like that. So I think what we want here is that the orbital speed necessary is going to be gm over 3r square rooted. The orbital velocity that is required does not depend on the mass of the satellite. And we said right from the get-go in this unit that a satellite, it could be a nature-made object like a moon, or it could be a human-made object like a communication satellite. The term satellite doesn't mean it's made by humans necessarily. Use part A to derive an expression for the angular momentum of little m around big M. One of the equations that we went through with angular momentum went something like this. The mass of the object times its velocity times r perpendicular. And in this case, we have m. V is that quantity right there. So let me put that in there. And then r perpendicular is that r that is perpendicular to the velocity, which is 3r. So what does this simplify to? Angular velocity. Do we want to combine the 3r's? If we do that, then I'm going to end up with a 3r in the numerator under the radical sign. I think it's going to be 3gm r square rooted.